Hello everyone, welcome to my YouTube channel. So today we will see uh, the RAG interview question, how to fix retrieval when top K fails. So suppose you are in a AI interview, and the interviewer asks, your RAG systems retrieves the top 5 chunks, but the correct answer is actually in the chunk number 12. Increasing top K to 20 exceed the LM context window. How would you solve this? If you simply answer increase top K, you are probably fail the interview. In this video, I will explain how production grade RAG systems solve the problem. So the problem statement is, let's visualize it. Suppose your document contains 100 chunks. Okay, let's suppose it is chunk 1, chunk 2, chunk 3, chunk 12. This is the correct answer, and the chunk 100. Your vector database retrieves top 5 similar chunks. Okay, so like your LM finds out like this, these are the top 5 similar 1, 4, 18, 27, 31. You notice something? Chunk 12 never appears. So the LM confidently gives the wrong answer. Many beginner increase top K from 5 to 20, but now you send 20 into 500 tokens means 1000 tokens. Imagine multiple documents, soon your context window is full. Now inference becomes slower and more expensive. The cost will also increase. So why this happens? Embeddings are not perfect. Similarity search finds semantically similar chunks, not necessarily the most useful chunk. So the reason include chunk boundaries, missing keywords, embedding limitations, query wording, domain specific language. This is called recall problem. So production RAG system focus on improving recall instead of blinding increasing top K. So first solution is, instead of searching once, we will search multiple ways. The original question, how can I reset my password? It generate variation, change password, forget password, password recovery, login credential reset. Each query retrieves different chunks. Merge the chunks. This dramatically improves recall. So the architecture of the recall is like, so user query comes in, the query will be expanded, multiple search happen, and then we will merge the results. Now this is the solution 1. Now solution 2. In solution 2, don't rely on the vector search. Combine semantic search and keyword search. So semantic search is the similarity meaning of that particular question, and keyword search, called as BM25, means exact word search. So why? Imagine searching Kafka consumer lag. So vector search might retrieve Kafka throughput, keyword search retrieves consumer lag. So hybrid search combines both. It will, so it will combine both vector search and BM25 search. So if we merge both, we will get better results. This is one of the most common production architecture. Now we have solution 3. In solution 3, instead of sending top 20 chunks to the LM, retrieve top 30. Then use a cross-encoder reranker. So reranker will re-rank all the top K. We will retrieve 30. Reranker will reads both question and chunk, then scores how relevant each chunk actually is. Now chunk 12 may become rank 1. Very additional context, huge improvement. Now we have solution 4. In solution 4, the parent document retrieval. Small chunks lose context. Instead, split document into small embedding, but return the larger parent section. For example, let's suppose how it works. Let's suppose the embedding is like paragraph 5. Now the retrieve parent is entire chapter of that paragraph 5. You preserve context without indexing huge document. Many framework like LangChain support parent document retrieval. Now the solution 4 was like parent document retrieval. Now solution 5 is multi-stage retrieval. Multi-stage retrieval. In this, the modern RAG systems don't retrieve once, they retrieve in stages. User question comes in, then vector search happen on, then Reranker happen, then context compression happen, and then it goes to the LM. The only best information reaches the LM. This keeps low cost and quality very high. So these are dependent on each previous solution. So user question comes in, then vector search, then Reranker, context compressor, and then it is passed to the LM, and this keeps cost low and quality high. Now there is a solution called context compression. So we need to suppose you repeat 10 large chunks. Instead of sending all 10, exactly only the relevant sentence. Example, original chunks contain 500 tokens, compressed can have 80 tokens. Now you fit more useful information inside the context window. LangChain call this contextual compression retrieval. So the production grade pipeline should how it's the final answer, final solution. So final solution is this one. Okay, user query comes in, then query will be expanded, means it will do a vector search also and BM25 search with it. Then we will merge both the responses from these both the searches. Then we apply Reranker, and then we will search for the parent document retrieval. We get certain context that these chunks we got, and from these chunks we will retrieve the parent document, and then we will check what will be the context, and that context will be compressed and then sent to the LM, and then we will get the final answer. So I would not simply increase top K because it increases latency, cost, and context size. Instead, I would improve retrieval quality using query expansion, hybrid search, re-ranking, parent document retrieval, and contextual compression. These techniques improve recall while keeping the context window efficient. The answer demonstrates the production level understanding. If you are preparing for applied AI engineer, mastering concepts like RAG, embedding, re-rankers, hybrid search, and context compression is essential. If you found this video helpful, like, subscribe and comment below. Rag mastery, and I will create a full interview series on production AI system design. Thank you.